So looking at some of these word problems with fractions, particularly how would we know if we're going to multiply or divide? And me, usually I actually do both. I multiply and divide. But what we want to do, or one indication sometimes, is that we can look for rates. Okay, we can look for a comparison of two numbers. So let's take a look at some examples of what a rate is. So some examples here, we could have 1 foot equals 12 inches. You might say that's an equation or an equality, but we could also treat it as a rate. 30 miles per hour, I'm driving in my car, 30 miles per hour, that is a rate, and we'll talk about what the numbers are there. I work at my job, I make $100 a day, that is my rate of pay. And perhaps in a classroom or something, there are 5 men to 3 women. Some people might call that a ratio, but we can also treat it as a rate. Very, very similar ideas there. So just remember that a rate is a comparison of two numbers. Could say that they're the same, could say that they're equal. Like in that first example, 1 foot equals 12 inches. Those are our two numbers. If I drive for, or if I go 30 miles, this one's kind of tricky. You got to remember the other number here. Per hour means 1 hour. So I'm comparing my distance of 30 miles to the time of 1 hour. Same idea here with $100 a day. 100 is one of the numbers, $100. A day, that's 1 day. So that's my other number. And then 5 men and 3 women, you've got your two numbers there. So let's take a look at some actual example word problems where we'll be given a rate and then asked a question. So hopefully there's a link underneath this video that will take you to a couple worksheets, but if that works, the first worksheet called Fraction Word Problems, this is number 2 from that worksheet. So we'll do this one as an example. It says, it takes 1/2 of a box of nails to build a birdhouse. If you wanted to build 5 birdhouses, how many boxes would you need? So we were talking about looking for rates, and I see a rate in here. I see 1/2 of a box of nails to build a birdhouse. Oops, excuse me, I need more than that. 1/2 of a box of nails, I need to compare it to something else, to build a birdhouse. So that whole thing right there is my rate. I'm comparing, I've got 1/2 a box of nails, I'm just going to say 1/2 a box, and then I'm comparing that to 1 birdhouse, and I'm just going to say 1 house. Okay, that's my rate. I'm comparing those two numbers, 1/2 of a box compared to 1 house. So reading the question now again, if you wanted to build 5 birdhouses, how many boxes would you need? So again, the question is comparing those. 5 birdhouses, how many boxes? Houses and boxes. That's what we're comparing. So there's lots of different ways to do this, but if you had me for whole numbers, you might remember my setup. I'm going to start with the 5 birdhouses. Right here, I'm going to start with those 5 birdhouses. So 5, and I'm just going to say 5 houses. And then I'm going to multiply, but I'm going to multiply by a fraction. And I'm going to use my rate. I'm going to use these numbers in my fraction. So one of them goes on top and the other goes on the bottom. 1/2 box is either going to go top or bottom, and the 1 house is going to go top or bottom. It'll go the other one. And the question is, which way is it arranged? Which one's top and which one's bottom? It's important. And again, if you remember, I have houses here, so that means I need to match that on the bottom of my fraction here. I need house or houses on the bottom. So that means for my rate, my 1 house, I have to put the 1 house on the bottom to match the 5 houses that I have for my whole number. Okay, so then that means that the 1/2 box has to go on top. And this does look kind of weird because we've got a fraction, and in that fraction we have another fraction. This whole thing is a fraction, and then there's a fraction on the top of the fraction, but that's okay, don't worry too much about that. So that's your setup. If you can get there, then you're doing good. From there, then you just have to remember, alright, it's just going to be that first number, 5, multiplied by the top number, which is 1/2, divided by the bottom number. So this is now the work that we're going to do. 5 times 1/2 divided by 1. Okay, and again, I know I say it a lot, but there are other ways to come up with this. Some people just realize that really all they have to do is 5 times 1/2. But me, I always say, well, how do you know that? This is how I know. that's how I know that I'm just going to do 5 times a half. Okay, because dividing by 1 really doesn't change anything. But anyways, when we do this, start with 5 times a half. And we have to remember how to multiply fractions. You probably want to make 5 into a fraction. 5 over 1 times 1 over 2. Remember, multiplying is the easy one. For those of you that like to cross reduce, we cannot do any cross reducing here, but we're just going to multiply the top numbers. 5 times 1, 1 times 5, which gives you 5. And then we're going to multiply the bottom numbers. 1 times 2 or 2 times 1, which gives you 2. So we get 5 halves. Now, we still have that divided by 1 piece, but dividing by 1 is easy. 5 halves divided by 1 is just going to keep it at 5 halves. Okay. If it was, you know, like half a box of nails for 3 birdhouses instead of half a box of nails to build a birdhouse, then we'd have to do that division. But dividing by 1 makes it easy. Anyways, the only other thing we would want to do here maybe is to say instead of 5 halves, maybe let's change that to a mixed number. That would be 2.5. And that is, again, the question is how many boxes, so it's 5 halves or 2.5 boxes, and that would be our final answer. Remember, I don't care which way you give your answer as long as it's reduced. That's all I really care about. So the second worksheet, that's hopefully there's a link for in the description below this. The top of that worksheet says unit fraction word problems, and we're looking at number 2 on that worksheet. So they say here, a glass of water was 1/9 of a liter. How many glasses would it take to fill up a 5-liter jug? So again, looking for rates, comparisons between numbers, I see here a glass, 1 glass, compared to 1/9 of a liter. Okay, so that's my rate right here. Okay, so they're talking 1 glass being compared to 1/9, there's my fraction, 1/9 of a liter, or I could just say 1/9 liter. So I'm going to use those numbers in a fraction. I'm going to put that 1/9 into a fraction and a fraction. But we'll be okay here. So now if we move to the question, so the question says how many glasses would it take to fill up a 5-liter jug? So that's what I'm going to start with. I'm going to start with 5 liters. Okay, and then I'm going to multiply that by my rate. And again, remember how we set this up. If I have liters here, that means I want liters or a liter on the bottom. I got to have that matchup. Okay, that liter has to go on the bottom. And in this case, it's going to be the 1/9 of a liter is going to go on the bottom. And that means that the 1 glass that I'm comparing it to, 1/9 liters compared to 1 glass, that 1 glass has to go on the top. So again, if you can get that set up, then you're looking good. From here, you just have to remember now what operations are you going to do, how do you proceed with the problem. That's your setup, though. That's the way I like to do it. So what I do here now, once I have that set up, is I'm going to do the first number, 5, and notice I can drop the words. I don't need liters anymore or glass. I can just do the numbers. 5 times the top number, 1, and then divided by the bottom number, which is a fraction. Okay, and again, some people might just go, oh, I'm just going to do 5 divided by 1/9. That works, that's a shortcut, but this is how I know that's going to work. So starting with 5 times 1, that's easy. 5 times 1 is just 5, so then it's just 5 divided by 1/9. And this is where now I have to remember how to divide with my fractions. So first thing I'm going to do is I'm going to change 5 to a fraction. My whole number is 5 over 1. And then I do the same change flip. So I'm going to change division to multiplication. First fraction stayed the same, change division to multiplication, and then flip the second fraction, 9 over 1. Okay, that's how we multiply. First fraction stays the same, change to multiplication, flip the second fraction, switch the top and the bottom. And now I go, hooray, it's multiplying. Multiplying is easy, cannot do any cross reducing, but multiplying the tops, 5 times 9, 9 times 5 is 45, and on the bottom, 1 times 1 is 1. Cannot be reduced, that's our answer, but probably a better way to say that is 45 over 1 is just 45, 45 divided by 1 is 45, and that is the question again, how many glasses? So this is 45 glasses. So now we've seen 2 problems using rates. One of them, the first one that we did there, you could have just done multiplication, but using the rates that I do, you do both multiplication and division. Same thing here, you could have just divided 5 divided by 1/9. That's what we came up with here, but this is how I know. Alright, now we're going to take a look at a couple examples where we do multiply or divide, but we don't use rates. So staying on that same worksheet, the unit fraction word problems worksheet, this is number 1. It says, a moving company had 1/7 of a ton of weight to move across town. If they wanted to split it equally amongst 8 trips, how much weight would they have on each trip? So if you're looking for a rate here, the only rate I really see is right here to say a moving company had 1/7 of a ton of weight to move across town. So you could say, oh, you're comparing the one company to the 1/7 of a ton. And that's true, you are comparing those, and you could make a rate out of that, but we're not going to use the rate here because there's no more mention of companies. The question brings in this new unit, trips, 8 trips, how much weight would they have on each trip? So really here the rate is not going to help us. Instead, what we want to recognize here is that we have this phrase about split it equally, okay, and that what really that is that's just division. Splitting it equally means you're dividing. You're dividing it equally, you're splitting it equally amongst 8 trips. So that's all we have to do, is we just have to take our 1/7 of a ton and divide it equally between the 8 trips. And that'll give us how much we would have on 8 trips. So really this is all we have to do now. So 1/7 divided by 8, remember your rules for division. It would be helpful if that 8 were a fraction. 8 is 8/1. And now, same change flip. First fraction stays the same. So I'm going to keep my 1/7. Change the operation to multiplication. Flip the second fraction to 1/8. And now I multiply 1 times 1 on the top is 1, 7 times 8 on the bottom is 56. No reducing. This is a proper fraction, so I can't change it to a mixed number. And that would be how much weight. We were talking tons, so it's 1/56 of a ton as my final answer there. So we'll do one more example here together. Back to that first worksheet. Up at the top of that worksheet says fraction word problems. Looking at number 1 here. So this is another one where we're not necessarily going to be able to use rates, but that doesn't mean we're not going to multiply or divide. So number 1 on that worksheet says, a chef cooked 8 kilograms of mashed potatoes for a dinner party. If the guests only ate 6/8 of the amount he cooked, how much did they eat? So again, if you're looking for rates, you might say, oh, you're comparing a chef with 8 kilograms. You could say that. A chef cooked 8 kilograms. So that's one chef compared to 8 kilograms. kg as an abbreviation for kilogram. You could also say, oh, you're comparing the 8 kilograms. It was for one dinner party. So you could say you're also comparing it to one party there. And again, that's true. You could make rates out of that. But looking at the question, we're not asked about chefs or parties. We're just asked about how much did each guest eat, how much did each person, or excuse me, rather altogether. The guests only ate 6/8 of the amount. How much did they eat? So even though you can spot those rates, they're not going to help us here. Instead, here's a shortcut that'll always work with fractions. When you have a fraction of a number, you can always do that fraction times the number. Fraction times the number. So a fraction of really means the fraction times the number. And I see that here. I see 6/8 of, let me switch colors just to make this stand out there. I see 6/8 of the amount he cooked. So that's not exactly 6/8 of a number, but if you go, well, how much did he cook? What was the amount he cooked? Oh, it was 8 kilograms. So we're doing 6/8 of 8 kilograms. That's really what we're doing here. We can rephrase the question that way, 6/8 of 8 kilograms. So again, that keyword of, a fraction of a number, means the fraction times the number, so we're really going to do 6/8 times 8 kilograms. Okay, so even though we might see some rates over here, one chef, 8 kilograms, one party, it's really not helping us to solve the problem, but instead a fraction of a number tells me that I can multiply 6/8 of the amount he cooked, 6/8 of 8 kilograms. So 6/8 times 8. Okay, so this is the work I have to do now. So again, it's helpful sometimes to write both numbers as fractions. 8 as a fraction is 8/1. So this is the multiplication I can do. 6 times 8 on top is 48. 8 times 1 on the bottom is 8, but this will reduce. Actually, remember, this is 48 divided by 8, so that's exactly 6. Or if you want to cross reduce, let me switch colors one more time here. If you want to cross reduce here, you could say, oh, 6 over 8 times 8 over 1. The 8 on the bottom will cancel with the 8 on the top. They'll both become 1s. 8 divided by 8 is 1, and the other 8 divided by 8 is 1. So now I've got 6 times 1 on the top, 1 times 1 on the bottom is 6, which is just 6. And then that is, we're looking at how much did they eat. We're measuring this in kilograms. So 6 kilograms would be my final answer, either way you want to do it. Okay, so again, look for those rates, but just realize that even if you don't have a rate, it doesn't mean that you're not going to multiply or divide.